All right, we're going to kick things off. So thank you, everybody, for attending our Ask Me Anything. I'm Luke Tuttle. I'll be the MC today. I'm the Chief Operating Officer at Ready Robotics. We're a robotics software company located here in Columbus, Ohio. Today, we're joined with our partner, Giovanni, who is the community lead for Tool Up Interfaces. And this webinar is being done in combination with Manufacturing Works, that we're pleased to be able to provide our learning content at the Ready Academy through Manufacturing Works. So I'd like to pass it to Giovanni to say a few words from him.
Awesome. Thanks, Luke. So yeah, great to be here. So I am with, as Luke mentioned, Tool Up Interfaces, manufacturing app platform that is part of the consortium of companies that helped start MFG.Works. MFG.Works is a community for manufacturers around the globe. Essentially, it provides educational resources, a place to go with questions, a place to go to share any information you have, and really interact with other manufacturing professionals around the world. So you can go to mfg.works and look at the content there. And like I mentioned, there is a lot of educational content, including the Ready Robotics Academy that was recently added that we're very excited to have. Awesome. Thanks, Luke.
Great. Thanks, Gio, for including us in Manufacturing Works. I'm going to let Kel and Jake introduce themselves, but the format for today's webinar is I'm going to read some of the questions that have been submitted over the last few weeks. Jake and Kel are going to have an opportunity to respond to those. If you have any additional questions or follow-up, please use the chat that's in your webinar window. But I want to start with a quick introduction, Jake and Kel. So Kel.
Yeah, absolutely. Thanks, Luke. So I'm Kel Guerin. I'm the co-founder and chief technology officer at Ready Robotics. And I have a PhD in robotics. I've been in the robotics industry for more than 10 years, focusing on a lot of different problems, but mostly on how to make robots more usable, which is technology that we then spun out into Ready Robotics, and that is really formed the core of our product in terms of how to make industrial robots easier to use. Jake?
Hey everybody, Jake Huckaby, the VP of Strategic Initiatives at Ready Robotics. Also have a PhD in robotics engineering and have been engaged in the industry for many years in terms of manufacturing industrial robots, standards, and safety. So I'm very excited to have a chance to talk to you guys.
That's great. Thanks, Kel and Jake. So we're going to dive right into the questions. So once again, thank you for everyone who submitted questions. Got some really good ones here. So I'm going to start off with the first question. Is from Saul. Address this to Kel. So Kel, given your background and your company, I'd love to get your take on the question about robots are taking our jobs. Do you think in the future factories will be fully automated, or do you think there's still a role for humans to play? If so, what is that role? And how can manufacturing workers prepare to thrive in a world that might include a lot of robots?
Absolutely. And that's a fantastic question, Saul. It's something that we hear a lot because there is this perception that robots end up replacing people in manufacturing positions. And that's just kind of not correct at all. In fact, most manufacturers cannot find enough people right now to do manufacturing tasks. There's something called the skills gap, where there's a huge amount of unfilled jobs where we actually can't find enough people who are capable of doing the manufacturing tasks that we need to actually fill those positions, which is why we need automation. But people continue to have a huge value in manufacturing and will continue to do that in the future because there are a lot of problems that robots can't solve, as even though they get portrayed in the media as something that is sort of this device that's able to do anything. Robots really need a lot of help from people. And while they are getting more capable, a lot of the work that we do is helping what knowledge that people have, that domain-specific expertise, inform the robotic automation that's actually taking place. So we see a continued value to people in manufacturing because they're the ones with all of that knowledge, right? If you take a manufacturer that's been making some, aerospace component, let's say, for the last 30 years, they know a lot about how to make that component. A robot doesn't know any of that. And it's really up to the person to instill the automation with the knowledge that it needs to be able to help them with that task. And that is a trend that you're going to see here with our narrative and products, is that robots are really a tool that's unfortunately very difficult to use. But the easier it gets to use, the more valuable people are going to be able to be, because they're going to be able to utilize that tool just as how they utilize every other tool out there, right? If we look at the manufacturing space, you look at machine tools like CNC technology, there was a lot of concern that machinists, people who use mills and lathes every day by hand, were going to lose their jobs. And none of them did, because CNCs just enabled more production and more efficiency. And all those people with the knowledge about how to make the stuff, they all stayed and prospered because of that technology. And we see robots as the same way, but it only works if, to your second point, if the people in manufacturing are prepared to actually use that technology. And I took a look ahead at some of the other questions. We have a lot of questions about education, and we're going to talk about that a lot. But the capabilities that a person has who works for a manufacturer, even if they're just a machine operator who isn't doing heavy engineering, but just using those tools all day long, those people are absolutely capable of using robotics, using some of the technological developments that we and other companies are working on.
Great answer. And another one I like to point out always is that we as humans are going to invent new stuff.
Oh yeah.
So, I mean, imagine back in 2006, what was invented? iPhone. There's manufacturing plants with 100,000 people in them. Another great story is ice production.
Oh yeah.
Ice used to be a terrible industry. There were kids, all kind of workers that were involved in chopping ice, distributing ice. They worked 7 days a week. We invented refrigeration, and now think what the global market is for that entire chain, from manufacturing of refrigeration equipment to servicing it. It created a massive industry because now more people can refrigerate their goods than they could with ice. And I'm a firm believer that as a world, we're going to keep on inventing new things, and we're going to need to be more efficient at it. And how do you be more efficient? Use robotics. So,
yeah.
So great answer, Kel. Let's move on to the next question. It's from Gio. And again, this is to Kel. So what are the biggest challenges you see in getting people who understand manufacturing processes and operations to start programming robots?
Yeah, and this actually kind of goes to our core mission as a company, because when we think about robotics, our thesis is that industrial robots are too hard to use. And this is a trend that I think has really held back robots in the world. I mean, if we look at the history of robots were actually invented and commercialized at the exact same time the computers were. And we see how computers have changed, our entire world. We also see how usable those computers are. Anybody can buy a computer and learn how to use it very easily and get value out of it. Robots haven't been that same way. And if we look at how computers exploded and how they changed the world, a lot of it was because of that usability. So when we look at the average manufacturer, we see really a technology that's not being utilized. And the barrier to using those robots is the fact that, it takes somebody like me with a PhD to get a lot of value out of it. And that's not right, right? We want anybody, and I mean anyone, anybody on this call, anybody, age 4 and up, right, to be able to program a robot, just like anybody age 4 and up can use a smartphone or use an iPad or use a computer, right? It should be a very accessible technology. So the problem that we're fundamentally solving that we think is transformative is when a robot, an industrial robot, is as easy to use as a hammer or an angle grinder or any other industrial tool, then people will get huge value out of it and start thinking creatively within the mind's frame of that tool, right? When you have a hammer, everything looks like a nail, right? Well, if you know about robots and they're easy to deploy, they're easy to add into a process, people are going to be like, well, we should put a robot there and there, right? It ends up being this very positive feedback loop, but it's all being held back because these robots are so difficult to use. That comes from a lot of different things, but primarily it comes from sort of the fragmentation in the robotic space. There's roughly 30 large robot companies that make industrial robots. There's almost 100 companies that are in that space, but 30 major ones, and they all have completely different programming languages and operating systems, right? So it's not even like once you learn one, you can sort of learn another easily. You have to sort of do all of it over again, right? And learning that one is an intensive process. It's weeks and weeks of learning just the basics of how to make a robot move, let alone actually doing anything useful with it, like actually tending a machine or doing something, right? So it's a huge lift right now for somebody to learn how to use a robot, which if you look at the history of computers in 1979, it was really hard to use a computer. And then the 80s came along and companies developed easy to use technology. Now computers are easy to use, and we're doing the same thing.
Cool. And this next question allows us to answer a bit about kind of how our software works. I'm going to define, before I pass to you, Kel, here, one of the terms. So it's from John. Kel, so what kind of experience do folks need to use no-code robotic automation tools? Mm-hmm. Is this something from or is there something that manufacturing engineers without robotics backgrounds can benefit from? And so I just wanted to define this no-code robotic automation. So this is core to what Ready Robotics does, is our software changes how the interface to a robot works. So today, if you wanted to program there, it's lines of text in most cases. And it looks like a programming language. So if you're familiar with C, Java, Python, even if you've done macro languages within Excel, those are textual programming languages. In Ready, we call it no code because it's a flowchart style where the nodes in the flowchart represent the objects you see in the space. So you'll see a gripper object, you'll see the machine, you'll see the robot. And that's where the term no code comes from in context of Ready. So I'll pass to you, Kel, and the question was, what's the experience someone needs to do no code robotic programming in automation?
Well, I mean, the short answer is none, frankly, and that's what's really exciting about no code. Is what no code does is it takes away the complexity of programming the robot. Now, it doesn't take away the complexity of automation, and that's something that we spend a lot of time creating knowledge bases and resources around as well. But the act of actually programming the robot is something extremely accessible. I mean, with our software, we've had machinists with no automation or robotic background at all use our software in minutes. We've taken a class of former coal miners and other professionals who had no sort of experience in any kind of technology or, short of their smartphones, or even sometimes they didn't have smartphones, they just had a feature phone, who were able to learn in a few days how to program and utilize a robot. And then it took a little bit more for them to be able to actually learn the industrial processes that the robot can do. So anyone can learn how to program a robot. When we talk about the manufacturing space, manufacturers are perfectly equipped for utilizing the devices because they already know how to do the task, right? They know what they need to do. They know how the piece of metal needs to go in the machine in exactly the right way so that I can cut it as precisely as my customer needs it, and it's of the highest quality. All of that is already knowledge they possess. What they don't possess is the knowledge of how to use the robot, and that's something no code gives them immediately. Right? It's like the Holiday Inn Express of robotics, right? In the next day, you're an expert because the tool set that you're using isn't writing a bunch of lines of code. It's all of these little building blocks that you have that all mean things you understand. Things like open gripper, move to position, wait, right? There's stuff that you can read it and go, okay, I know what this is going to do, instead of just a bunch of lines of code of, Greek, right? That you don't know what it's going to do, right? And that's the differentiator. It's something that's very accessible so that anyone can look at it and go, okay, I know what this is going to do. And within a little practice, be able to utilize that for the business they already know, for the tasks they already are familiar with.
Excellent. So I thought I'd throw in just a couple. We're getting some questions coming in that I can get some quick answers to before we get to the next one. So this one comes from David, and the question is, with so many startup robotics companies out there, how do we suggest consumers research these brands beyond traditional big brands? Because there are about 10 brands that take up the majority of the market: Fanuc, KUKA, ABB, et cetera. On the Ready Robotics site, and I'll broadcast the link, we have a what we call the robot selector that has over 800 robots from over 70 brands, and it's interesting to use that as a starting off point to see what the range of options are in robotics, and you can search those by collaborative or industrial and the different sizes as a place to begin. And right now, it kind of speak to our other value proposition beyond easy programming, is that we provide the same interface no matter the robot brand, is there hasn't been a lot of incentive for different kind of organizations or companies to present a lot of robots from different brands in one place. So we think this is a good resource to kind of start some of those investigations. And there's a lot of new and up and coming brands that are out there. So we'll keep adding to that library. So thank you, David, for that question. I'm going to move on to the next question to Kel, and it was from Geo. And it is, how do you think the robotics landscape within factories will be different in, say, the next 10 years?
Absolutely. So I think that the way that we're going to see factories change is ideally you're going to see a lot more robots, but that's sort of a very simple way to answer that question, and kind of obvious, because with technology like ours that start to make this easier, again, the proliferation of robots into factories will definitely increase. I also think that what's driving that is not only the fact that robots are getting easier to use, they're also drastically reducing in cost, right? So right now I can buy a robot for, $13,000 that 10 years ago would have cost me close to $50,000 or $60,000. And there's already robots that are sub $10,000, even like a $2,000 robot that can do a lot of tasks. And so I think you're going to see a lot more sort of low cost robots that are used everywhere. And I think the other thing about that is it allows factories and manufacturers to be a lot more agile with their automation, right? A lot more experimental, right? When we think about the companies that really succeed right now, when we think of companies like that we hear about a lot, Tesla, they're companies that iterate all the time, right? They are constantly improving their process at a very rapid scale, at almost an uncomfortable scale. And automation hasn't really fit that model in the past, right? It takes a lot of planning. Things are expensive. You have to put up all this stuff, right? You have to train your personnel. There's a huge amount of overhead to putting in an industrial robot, in the past 10 years. And now it's much, much faster. We've had customers deploy a robot in a couple hours by themselves with no training, right? They just read the manual and go through the tutorials and they're done, right? And what that means is now, instead of being caught in this catch-22 where I have a process that I think I can use a robot for, but without actually spending the money and putting a robot there, I can't prove that it's worth it, right? I can't prove my ROI. Now you can just take a very low cost robot and try it out, right? You can actually try out automation and see if it fits. And then if it does, you can either leave that there because it works great, or you think about a faster robot or a heavier duty robot, but you can actually be agile. And I really think that this is going to change how companies think about their sort of overall automation strategy in being able to rapidly deploy these systems. The other thing that's important is about the fact that we see technology enabling, specifically ours, enabling the same user interface for any robot. So when we talked about our software where it's very easy to use interface, that works with any robot on the market. And the reason that we made the choice to do that is because we can't have the situation where you learn this really easy to use interface and then you need a bigger, faster robot, and that company doesn't support that bigger, faster robot, and some other company does, and now you have to learn something new, right? You need to be able to pick the right tool for the job that it needs to do without learning anything new. And what that means is now companies are able to pick the right device for the task that they have, and also pick the right vendor. You know, they don't have to be locked into a specific vendor and then end up having to switch vendors or something just because they want that new robot that can do that new thing. They don't have to make that decision anymore. Just like if I buy a new laptop because it has a better graphics card than the one I was currently using, I don't have to relearn how to use an operating system, right? I have that choice as a consumer. So I think overall, it makes companies able to be much more adaptive and agile about how they use automation, which just means they're going to use more of it and they're going to adopt that automation more rapidly.
Awesome. And to me, there's an answer or a question that came up as well that I think goes a bit with your answer there, Kel, is how do you guys think that robots can be more incorporated upstream in the manufacturing process, specifically in the design and development stage? And I give a quick answer. My perspective is, as Kel was discussing, as we make robots easier to use, then they do become more of just a tool. So traditionally, you've had product design, and then you had manufacturing, and the product designers would design products, and the manufacturer engineers are going to determine how to actually build that product. And as such, they may not be able to fully optimize for things like cost because the design of the product didn't incorporate thinking about automation. One way to address that, as Kel was discussing, is with an agile team, particularly one that's cross-functional. So you could imagine having a team that's a mixture of product designers and the manufacturing engineers, but both of them are adept at automation. They've gone through some training, they've had some exercise in how automation works. And in addition to that, they may have been able to also be hands-on, because as we make things easier to use, the barriers to entry are lowered, which means you can think about doing more prototyping far earlier in the process. And that prototype could either be done in a physical world, which could work in a lot of scenarios, but we also see where simulation will become a much more common activity. And one of the other things that Ready enables is that you can program in the simulation environment in the same way that you can in the physical world. So that's an important way that the skills are the same irrespective of the environment that you're in. So, so I think, as Kel said, they're like making it easier to use. The robot easier to use means we can have more focus on all the other pieces of automation and build other kind of skills.
Yeah.
So we're going to move on to some questions to Jake Huckaby. And the theme of these is somewhere around collaborative robots. So our software works with robots, whether they're collaborative or industrial. So collaborative robots are ones that came around in the last 10 or so years that are meant to work more closely with humans. They're able to do that because they have a number of features that make it so that if it runs into a person or encounters excessive force, that the robot will stop. An industrial robot, many of us have seen these videos of these robots on these large automotive lines, and they're moving car parts and things. Those robots will move where they're going pretty much no matter what. If there's a human in the way, that human's going to be injured. And that's why in those facilities, you'll see large cages and other safety devices surrounding those robots. Collaborative robots are something that came up that have additional sensors in them that make it so that they're less likely to injure a worker who's next to it. And it's important with all robots, and Jake's an expert in this, that there's always safety assessments done in a robotic application to ensure that what that robot is doing is safe, whether it's with safety guarding or it's based on the type of task. So with that bit of context, I'll hand it off to Jake here with the question from Roy. Is speaking of robots, nowadays people talk about Cobots, and that's short for collaborative robots. robots that work alongside humans. Which approach do you think is going to prevail in the next 5 to 10 years? Fully robotic automation or using collaborative robots?
Sure. That's a great question. I think it's good to have some context, and Luke did a great job of giving us, I think, an overview of, kind of what the concept of collaborative robots is when we're talking about it. It's an interesting thing. Collaborative robots as a class of robots is almost a little bit of a misnomer, right? Because you can take the softest, safest robot in the world and put a saw or a butcher knife on the end of it. There's not a lot of safe things you're going to be able to do with that robot. It really has to do more with the application. So in fact, speaking from a standards perspective, really talking about collaborative robot as a piece of hardware isn't something that we do much anymore, because we don't want people to have the misunderstanding that, well, I bought a robot and it's a collaborative robot and I installed it, and so I can do whatever I want and not have to worry about it. No, like Luke mentioned, the thing that you really have to do is you have to have a risk assessment to determine whether the entire application that I'm looking at is actually safe. But when you do that, these robots or cobots that have these types of safety features allow for humans to be within the workspace of the system while it's operating, either physically interacting with the process, either a joint assembly operation or some sort of a handoff, or just being alongside the robot. Maybe I'm working on the line while the robot is beside me doing something else on the line, right? It really enables an entire class, a huge class of different kinds of applications that just weren't possible before these technologies were available. And there are a lot of different kinds of enabling technologies, from active scanning technologies to, force sensitive technologies. It's a really exciting area. And again, enabling a lot of applications that we just weren't able to automate before. In terms of, where we see kind of the direction going for the technology and for the industry, I think that what you're going to see is kind of a merging of these two concepts, right? As technologies continue to advance, and there's some early technologies out there right now that you can put on one of the big robot arms that are moving cars around, that potentially could allow that application to be determined as collaborative. So it really is an exciting time, because these new technologies are allowing us to enable potentially any robot, small, cute robots to large, scary-looking robots, to be used collaboratively with humans. And I think what you're going to see is a continued push to being able to automate more and more applications that we traditionally haven't been able to automate.
And there's a follow-on to that from Roy, Jake, which is, I think you covered a little bit of this, but what are the challenges with integrating collaborative robots specifically?
Yeah, it's a good question. It's an important question. I think that, first and foremost, again, is recognizing that it's much more about the application than the robot. The robot has to have these types of safety features, but understanding the environment, understanding the parts that you're working with, the process that the system is being integrated into, is important and can be a challenge. Not to get too into the weeds, but I think that again, as part of a comprehensive risk assessment to make sure that the application that is being implemented is kind of within guidelines per accepted standards. Making sure that my robot isn't going to exert above some force threshold or some pressure threshold that would lead to some sort of injury. So, with traditional industrial robots and installations, typically you don't want contact between users and the robots, right? That's why often you'll see a cage around these robots, right? You don't want your operators or your engineers interacting with the system. With a collaborative system, that's not the case. Often you expect or want that type of interaction to happen, right? That's a desired outcome. Is I can physically interact with the system, and so there's a bit more responsibility on whoever's doing the integration of those systems to make sure that those interactions are safe. So that, I think, is certainly different than the way that we look at traditional industrial robot installations.
Yeah. The other thing that, Jake, at one point you mentioned to me was when we were talking about capability, one of the challenges is making sure that a collaborative robot works for the lifespan of that cell, because a lot of people will look at a collaborative robot and think about the safety aspect, but then they'll forget that half the parts that they make with that process are too heavy for a collaborative robot. And so we've seen that before. Do you want to talk about that a little bit?
Absolutely. Certainly capability is a big consideration. I think Luke talked about it with the robot selector, right? Thinking about the system that you're going to be using and how you want to use it long term is certainly an important aspect, because for some of the enabling technologies, I'm thinking specifically like power and force limiting systems, like your universal robots systems, or your like your TM robots. They're going to be limited in the amount of payload that they have, and then they can handle. And with the heavier payloads, they're going to be speed limited because of the mass of the system moving around. It's just one of the limitations of the technology as it exists today. So paying careful attention to the requirements for your application, how fast does it need to move, how much weight does it need to carry, and to your point, Kel, are there other things that I may want to do on the system later that suddenly I can't do because I undersized my robot? So I think it's important to pay even more careful attention than you normally would when you're looking at some of these cobots and those technologies.
Excellent. And just to kind of wrap up, we have some new question, or the next set of questions around our Ready Academy. But one of the questions that came in were, how do we define ease of use? So Kel, could you just briefly kind of, because we use that term a lot. What does that mean to us when it comes to robotics?
Absolutely. So when we talk about ease of use, we really are focused on the programming of the robot, making the robot move around, and also making the robot talk to the other devices in the work cell that it needs to in order to do the task, right? I have my robot, I have my gripper, I have the machine tool that it's working with, I have some sensor that's making sure I have a part, all of those things. It's really about getting those and orchestrating them together so that they actually do the task that I want. So when we talk about ease of use, we're talking about that specific problem of taking all of the different capabilities the robot might have, all these sensors, the robot itself, the motions it can make, and boiling that down to something that does the thing, right? When we talk about ease of use, it's really how fast I can do that process, how quickly I can learn how to build programs that actually create value for me, and how well I can take that knowledge and apply that to other robots. That's what we're really talking about when we're talking about ease of use. And that focuses on, and what goes behind our technology in order to satisfy that is a lot of things that you would typically call user experience, really good design around user interfaces so that it's easy to look at this thing and understand which buttons I need to press to make it do what I want it to do. Also, the mental model, right? When we think about being able to take this task flow, the step-by-step things that the system has to do, instead of being lines of code, it's this sort of logical diagram that you're creating. So those are the things that we're talking about when we're talking about ease of use, but it really fundamentally comes down to programming a robotic work cell as easy as possible, as quickly as possible, so that it does the correct thing.
Excellent, thank you. So we're going to transition to a few questions that are about our Ready Academy. So the Ready Academy is an online resource that provides coursework in automation. So we specifically say it's not just about programming robots, it's learning how to automate things with robots. And as part of that, you will learn how to program a robot with no code. Kel, the first question is, there's a lot of talk about upskilling and reskilling these days. So first of all, could you define those as what they mean to you? And then how does Ready Academy fit into the efforts to implement upskilling and reskilling?
Sure. So when we talk about upskilling, what we're talking about is people that are in the manufacturing space that we want to give them a new set of skills, in this case, to be able to work with robotic automation. Reskilling is similar, except we're usually talking about people that are outside the manufacturing space. For instance, we'll talk a little bit more about our work with eCami, which was a group of people who were not in the manufacturing space, coal miners, people who worked in commercial, places like Lowe's, stuff like that, right, where they are not manufacturers. That was what we would consider reskilling, just to define those two words. So when we think about that, it's really about how easy is it for you to learn this specific topic and actually, importantly, create value with that technology, right? It's not just that I can press buttons on my phone and it lights up and it looks cool, right? I want to do stuff with it. I want to check my email. I want to play that game. I want to have something meaningful come out of my interactions with that device. And so the Ready Academy was really built with that in mind, because a lot of the educational content that's out there for robotics, for upskilling people to use robotics, is really focused on learning how to use the robot to make a piece of metal and motors and electronics move around the way that you want it to. All of the other stuff, like how does it pick up parts? Where do those parts go? How do those parts go into the machine? How do I talk to the machine? What do those parts look like if they're different when they come out and when I put them in? How do I still hold them again, right? All of those different pieces about the actual value creating task are what you learn in Ready Academy. And the reason we're able to do that is because, again, of this ease of use. When the software that you learn in Ready Academy, which is a software called Task Canvas, sitting on top of our Forge OS operating system. When you learn that software, you're learning how to program a robot in a couple of days. And that's deep, deep knowledge about how to program that robot, how to make it do all of the things that you needed to do. But you're not just learning that. You're also learning how a robot fundamentally works, how it represents its information in its environment, how multiple robots that are differently shaped differ in how you work with them and control them, and what that means for your task. We also dig into the actual application side. How do you hold parts? We have content in Ready Academy on gripper finger design from one of our partners who specializes in grippers and gripper fingers. We have content on how to place parts so that you can repeatedly grab them so that they don't move around, because robots don't like when things change position unless you have a camera, and then we talk about that too, right? So it's all of those different pieces that you actually use to create a value creating task, not just programming the robot. That's really the differential between what Ready Academy is and what some of the other robotic courses that are out there. Besides the fact that you're going to walk away from Ready Academy being able to use that skill set for any robot, right, that runs Forge. That's the sort of coup de grace of that.
And that's a great point there, and it answers one of the questions, which was from Franklin, and it says, is it true that Ready's programming platform doesn't change, and they put emphasis on, at all from one robot to another? If I'm able to program a FANUC, can I instantly program other robots?
Yeah, and so the answer to that is yes. And in fact, we might as well talk about Huckaby a little bit. So Huckaby is the East Kentucky Advanced Manufacturing Institute. They're down in Painesville, Kentucky. They're this amazing institute for teaching people how to use CNC technology. And we worked with them to create a robotics curriculum, which then we wrapped up into sort of the core fundamental course at Ready Academy to teach them how to use robots on top of now being able to use CNC tools. And the important piece there is that course was taught with 4 completely different robots. We had a universal robot, which is collaborative. We had a collaborative Yaskawa robot. We have a collaborative FANUC robot, and then we had a non-collaborative FANUC robot. And so they were literally on a daily basis programming 4 pretty different robots, both from different brands, different underlying software, which they never saw, right? They just saw Forge, different, form factors, right? Different capabilities, because 3 of them were collaborative. 1 of them was a much faster and stronger non-collaborative. So they got to learn about what's different about those 2 robots. As Jake was saying, there's a lot that's different. So we were able to impart all of that knowledge because they really could focus on that, and because the software worked on any of those different robots. If we had another robot in there from Nachi or Kawasaki or Epson, it would have been exactly the same. You would have been using our software on that robot, and then you would have been learning how the device works, right? It's like learning how to use a hammer. Learning a big sledgehammer is slightly different than learning like a little, ball peen hammer, right? You use it for different things and you respect it in different ways. Same thing with robots. A big, gigantic robot needs to be treated a little bit differently when you're programming it than a smaller, faster robot, for instance. But the software that you're using to program that robot shouldn't be any different. It should just be the same, right? And that was really transformative and allowed the content that we then wrapped into Ready Academy to do that same thing. So if you go to Ready Academy, which I encourage you to do now, it's completely free. You can sign up and there's 40 hours worth of content there. You'll see that when we actually do exercises, half of them are done with the Yaskawa and non-collaborative robot, half of them are done with the Yaskawa collaborative robot, half of them are done with a FANUC non-collaborative robot, because from our perspective, they're the same. They have different capabilities, but the software is identical.
Excellent. And since you brought Huckaby up, Gail asked a question that she'd seen the video before and asked, what are the options for other educational institutions, such as tech centers, schools, to make use of these automation courses? So as Kel said, the Ready Academy is open and available, but I'm currently also leading the effort to do some pilot programs. So Gail, I'd be very interested in talking to you if you're involved in an institution to discuss how we could work together and pilot our training in your school or institution. And we're putting together also some packages for STEM programs. So more to come on that shortly. But this is where we see a lot of value, particularly from a STEM perspective, is a person learning how to program a robot on a very low-cost robot. And we're adding more and more brands of robots over time. And the intent is to support some very low-cost robots that you could use in a STEM scenario in like a primary or secondary school, and show to those students that this same programming language is being used to program this FANUC that can carry 1,000 kilogram, a very heavy weight around. And the students will recognize that these are the same skills, and I'm learning this very early on. So very interested in hearing about from anybody who's interested in using our courses. Is that something we're actively developing? The other question here was from Justin about the coursework that we have, and the questions. I've taken some of the Ready Academy courses, and they're great. What's the plan to add more lessons? What's next? So we just added some coursework on basic machine tending. We're adding some more on advanced machine tending, and we're going to start to have some regular communication to the folks signed up for the Ready Academy about what courses are coming next. So there's a lot of different content that we're going to add, and we're also going to have content from our partners. As Kel mentioned, we have Shunk, who makes gripper finger or makes grippers, has a course on gripper finger design. There'll be more of that kind of activity to come. So the next question, let me jump around here. I think we answered that. One is actually from a customer, Steve, and this said Ready Robotics customer here. Their deployment went very smoothly, and it says we had our robot up and running in about 2 days, which is fantastic. That's the kind of feedback that we love to hear from our customers, that they receive the robot and they get it up on their machine, automating, making parts as quickly as possible. And the question is, what is the best way for current customers to leverage Ready Academy, sequential or some other? And one great thing with learning is there's always something new to learn. There's always a different way to do something. So I think in each of our courses, you'll find a new way of doing something that you developed on your own. Since we make it so easy, there are still multiple ways to accomplish the same task. And where the coursework becomes useful is as you think about, how do I make my process go faster? Maybe I haven't gone lights out yet. So I'd like to learn about that. So I don't think sequential is necessarily a requirement. I think the courses are organized in a way that you can kind of find the coursework that is interesting to you, that's addressing something that maybe is the next step in your own journey in automation. But we'd also love to hear your feedback. And if that's not clear, maybe we can help provide some better guidance for how the courses are arranged. And that's something that we could enhance on the site.
So just to jump in on that, because that's an awesome question, and I'm so glad that you're having so much success with our product. The other thing that you can think about is other opportunities for automation, and also other people in your institution that might benefit from taking that training as well. We find that, what's amazing about manufacturers is there's so many creative problem solvers in manufacturing, and the ability to, constantly be tweaking and improving a process. Anybody who does that all day long would benefit from this course material, because as we've been saying, the robot just becomes another powerful tool in their belt to solve problems. So if you already have gone through the training and you're looking at your first robot application, or you're looking at subsequent robot applications, find other people as well who might be interested in taking that coursework, because it really gives them that new lens to look through to solve problems.
Excellent. Move on to the next question here. I'll throw this one to Jake. This question's from Taylor. Feels like automation has been here for a while, at least with major manufacturers like Big 5 automakers, which is very true. The majority of robots are in the automotive sector, and I think we've all seen movies with lots of robots on these large manufacturing lines. So Jake, what are the keys to enabling the rest of the manufacturing sector to leverage automation?
Sure. Great question. I think one of the things that Kel hit on earlier that I think is going to make a really big difference is the advent of low-cost automation solutions. Cost, I think, has been one of the big hurdles for especially SME type manufacturers to get into automation. It's it can be difficult to explore whether or not an automation solution or an industrial robot makes sense for an application if you can't test it out. And often the barrier to entry, the cost, is just too high. So having the availability of low-cost solutions, I think, is going to have a really big impact on the ability for not just automakers, to be able to really get into automating their processes. Another barrier to entry, again, that Kel's touched on at length, is the difficulty of programming. Programming robots, programming other automation components. It's a pretty steep learning curve. And the solutions like Forge from Ready Robotics is I think part of the response to that. As these types of solutions become more widespread, I think manufacturers are going to pick up on it. I think it is a huge win for them, because now that learning curve is mostly gone. So cost and making it easier to program, I think those are two key things that are going to help everybody else be able to leverage automation to improve their processes and make things better.
Great answer.
Yeah, I mean, what's so interesting is, like, you know, in 5 years, we could have a robot that costs less than $2,000 that does 80% of what we might need to do in manufacturing, especially when we talk about pick and place, right? You know, we talked with this customer recently where all of their workers were encouraged to use many 3D printers that they had all over the place. Like, anytime you saw a problem with a machine, you tweak something, use a 3D printer. You don't have to get a budget approval, just use it, right? Try it out, make something that fixes that issue, right? Imagine if I have a rack of robots on the wall that if I see something that I think it might be able to be automated, I can pull one of those robots off and in 5 minutes have it doing something meaningful just to try it out. And maybe we end up going with that direction. Maybe we end up, you know, maybe it wasn't a good fit, but you're able to try it out that fast and at that low cost point. That's where things get really interesting in terms of how manufacturers will think differently about automation.
Excellent. And I'm going to answer this next one. It's from Tom, and it says, what do integrators think about this technology that makes it easier for manufacturers to deploy their own robots? And while Ready makes robots much easier to program, automation still requires there to be work to be done in terms of the robot needs to be mounted on a pedestal. It needs to be wired into the machine. You might need to run new power to where that machine is located. You might need to move machines. There's a lot of project work that is still involved with implementing automation that can still make sense to use an integrator. So we think there'll likely be more of a hybrid approach, where some new cells are done on a project-based approach using an integrator. Others are being done by in-house automation teams. And as Jake said, a lot of this is driven by cost. So certain cells will justify a higher cost where there may be a need to implement it more quickly. That might be a good opportunity to use an integrator. Then there might be other solutions where the cost just cannot be met using an external integrator. And also maybe the time frame is capable of being done with internal resources. And I see this as the exact same parallel to how software integrators work in business applications. So many IT departments at enterprise and small businesses are able to implement a lot of their own software, but they also go to large and small integrators, the Accentures, the Deloittes, and et cetera, that are doing very large system integrators. And there are hundreds and thousands of boutique software integrators that do software projects. Some of those are very small, and they're also doing analysis projects. So as an analog, software is ubiquitous, right, in business, and the applications are pervasive. We think that same thing is going to happen with automation, where there's just so much automation going on. There's still an opportunity for project work. So I think integrators are still going to have lots of business. In general, they're heavily backlogged right now. And as a customer, if the integration project cost goes to below a certain point, the integrators aren't interested because they can already find enough projects that are above that threshold that is a lower risk for them to do at those prices. The follow-on to this is, what do robot OEMs or robot brands themselves feel about Forge OS? And we feel, and many of our discussions with them support this, that their interest is selling more robots. So what do we want to do? Sell more robots. We are not in competition with robot brands. In fact, we want them to sell 10 or 100 times more robots, because there'll be 10 or 100 times more customers with robots that can be customers of Ready Robotics and our software. So we want robots to be as ubiquitous as the phone that's in your hand or the PC that you're using. So we'd like to see much more penetration of robots, not also just in the manufacturing. It could be food work, it can be laboratories when we think about COVID. Some of the challenges in testing is there's humans involved at different part of the chain. So what if we could automate more of that? Well, maybe the cost just doesn't make sense today, but what if the robot is a quarter of the price? Or if the lab technician can program it themselves with a specialty application that's built on top of that in a more cost-effective way. So we don't see as competitive in the discussions that we have had with the robot brands. Many, if not all of them, are supportive because we just want to sell more robots. We just got a couple minutes here. So Kel and Jake, why don't I give each of you just maybe a couple minutes for a final wrap up. Jake, I'll start with you, and Kel will give you the last word. So Jake, any final thoughts here to leave with the group?
I think we've had some fantastic questions. I think there is a lot to be said for the state of the robotics industry right now. As I said, it's a really exciting time. A lot of fantastic new technologies are coming out. We are seeing and will continue to see an increase in the number of applications that can be automated. It's just very exciting. A reminder, everybody, do a risk assessment. Thank you.
Thanks, Jake. Kel, final words.
Absolutely. And again, these have been amazing questions, and it's a pleasure to be able to answer them. I think what really excites me about all of this is the fact that we're looking at a future where robotic automation is ubiquitous, right? Where we're not going to be having these kind of conversations 10 years from now. Robots aren't going to be a thing. They're not going to be something that requires complex thought about how to use it or how to find value from it. It's just going to be a given, right? Just like how laptops are a given. Nobody stresses out about what their value they're going to get. They just buy it and use it, right? And that's what I'm excited about, and is the fact that robots will get much lower cost. They will be able to address more, because what we didn't talk about and didn't have any questions about was the other technology that's out there. There's tons of innovative technology that's improving the robot's ability to do tasks, right? Bin picking, advanced vision, artificial intelligence, all of that stuff is making the robot a more useful tool. But it really comes down to our ability to understand and sort of synthesize that tool and then put it to work. And I think if we focus on technology that allows everyone to do that, then you're going to see robots everywhere, like Luke was saying, not just in manufacturing, but in coffee shops, in your home. It's just going to be normal, just like computers are normal. And that's what is really exciting, because not only will it be an amazing industry that will support a ton of people, again, back to people, right? It will be, there's a lot of problems out there that automation can solve, and now it'll actually be able to solve them. So again, thank you so much. This has been fantastic. Thank you for all coming to this and asking great questions.
I'll second that. So thank you for everyone who attended. Those are online. Those who are going to be watching this offline, since replay is available. Especially like to thank Tulip Interfaces, where Gio's the community lead, for helping to promote this event. It was actually Tulip who I met originally at a session back in when we could actually go to events in January at the World Economic Forum. That led to us being able to be participants with Manufacturing Works, which, as we said, was an initiative led by Tulip and being on that council there. So Gio, thank you very much to yourself and to Saul, who can be on the call today. And I don't know if any final words, Gio, there.
No, I mean, this is what MFG Works is all about. I mean, great content like this is a really interesting session, and thanks everyone for the time and sharing all these interesting thoughts.
That's great. Well, it's been our pleasure for Jake and Kel, myself, the rest of our marketing team, Eric and Kirk, and once again to our attendees, thank you for taking the hour out of your day. If you have any follow-up questions, please do not hesitate to reach out to us directly, and we'll get back to you quickly. So thank you very much. Have a great rest of your day.
Take care. Thank you.
Take care. Bye-bye.